Quick little couple of applications here. You're not doing the lab uh, yet. We will get to that. Here are some practice problems. This one I want to just bring to your attention. 2 to the 2x times 2 to the third minus 7 times 2 to the x times 2 to the first plus 5 equals 0. So what happens with this one is we have 8 2 to the x squareds minus 14 2 to the x plus 5, and you're going to try to factor this. We're going to let w equal 2 to the x. So you have 8w squared minus 14w plus 5. You just go ahead and factor that. And I'll let you try those too. They're pretty good. Here's some other ones for you to practice. Terrific. A couple of applications. Growth, exponential growth, always starts with an amount and ends with some mystery amount. The initial amount is times e to the kt. And this growth constant e, you can use any base you want, 2, 3, 4, but we'll keep it at e because it's easy to work with. And then k is what we always want to find first. And then we can find whatever we need. So in year 0, I'm going to say year 0, you have n equal to 14 mega bunnies. There's something creepy about these bunnies. I don't know what it is. For year 3, we start with 14, we end with 44, and we don't know k, but we know it's 3 years. So you can kind of see that 44 over 14 equals e to the 3k, then log base e of 44 over 14 will be equal to 3k. So if you took k equal to natural log base e, 44 over 14, and divided by 3, or multiplied by 1/3, then you'll have k. Once you have k, then you go to the next part of the problem, and it says, how many bunnies will there be on year 8? So we want to find how many bunnies there'll be. We started with 14. We go e to the, whatever that is, ln of 44/14. What was that? Divided by 3 times a third. And then you'll get your new number of bunnies. Round down to get the whole number. Radioactive decay, you start with a certain amount and you, start with a certain amount and you end. So you start and then you end. Okay? Let's see. Isotope 131 doesn't affect the problem. How well will the thyroid be functioning? Suppose daily iodine 131 follows a model and that the half-life of iodine is approximately 8 years. So we're going to do half-life. It's t equal to 8 years. So we're starting with a certain amount and we're ending up with half of it. You can put any number you want. Times e to the k, t is 8 years. So 1/2 equals e to the 8t. So the natural log base e of 1/2. See how often we use that secret to logs? 8 times t. T is the natural log of 0.5 over 8. Because it's base e, it won't simplify. All right, if 5 grams of iodine is present, finally find the function which gives the amount of iodine in grams. So with this one, if 5 grams is present initially, so we're going to try to find out how much there'll be. We have 5 grams, or 5 times e to the same k, whatever that is, ln of 0.5 over 8. And that should help you find out how much you'll have after that amount of time. Okay, and so you can look at growth of money. I'll let you look at these. You just pretty much just use those formulas. But I just wanted to show you what to do with this number 1 here. Find the decay constant and round to the nearest 4 decimals. Okay, so here's what we have. We have an initial amount, N0, of 50 grams, a half-life. T is equal to 5.27. You're going to find a decay constant, function, and how long it takes for 90% of the material to decay. So we're going to go 1 equals 2 times e to the k times, I think the number of days was given here, 5.27. So you can solve for k, log base 1/2, log base 1/2, right? I think that's e of 1/2 equals 5.27 k. So whatever the natural log of 0.5 is over 5.27, that's going to be your k. And then you're going to use that in the formula. And I just want to show you this one. When they say 90%, determine how long it takes 90% to disappear. So if we started with 100%, there's only 10% left. Okay, so you could see finding time here if k was whatever that was that we had, and you just solve for t. Good stuff. There's a couple of these, and using these formulas. So these applications should go great. Here's another regression. You're going to use a different function this time, and notice how slick that data is. And I don't think you have to do these investments. We're going to skip that. This one isn't too bad. 25 and 37, that should be it. You don't need to do day 3. So just do a few of those word problems and those solving ones.